Now, if, when you see all this business on that last exam, if you can find on the unit circle right now an angle, a spot, where if you place y over x, you get -2. You place the y coordinate over the x coordinate, you get -2. You can sit there all day, it's not there. But yet they're asking for an answer. So, Ignacio, I gotta be clever again, we gotta be clever. So the best I can do right now, I will not ask Mr. Park to check this one. All I can do is this. I can sketch and show you where the angle is located. I don't know its size myself. It's not on the unit circle. Okay, guys, inverse tan 2, boy. Y over x is supposed to be a negative. Now, where is y over x in the 4 quadrants? Where is y over x negative?
2 and 4.
I heard 2 and 4, okay? Now, I gotta place it in just one quadrant. Can't be in two quadrants. So it's, right now at this point, it's either here, Professor, or it's here, because the coordinates here were this, and the coordinates here in quadrant 2 was this, and if you place y over x, you get a negative. At least I know negative. Got the negative out of the way. Which of the two should I accept? It depends on my restriction, which I erased, on the inverse tan. Can someone remind me what that restriction was for inverse tan? Negative pi over 2 over to what? Positive pi over 2, not including. And we just did this today. Guys, here's the translation, which will help you out. If I'm caught between negative pi over 2 and a positive pi over 2, am I actually caught between, here's negative pi over 2, here's positive pi over 2. Does that make sense? If I go this direction, it's -90. Go this direction, it's +90. So which 2 quadrants am I covering with this? 1 and 4. Am I in one of those right now?
4.
I'm in 4, so that's where I stay. Based on this restriction, I'm in 1 or 4, I'm in 4, and therefore this quadrant 2 is out, it's not there. So I know right now, and watch carefully, I'm in quadrant 4. Let's make a sketch here. The angle's down here. What size is it? I have no clue. I have no clue. That's down here. Let's call it theta. Guys, they want cosecant of it. Now, the best I can do, and you've got a quiz coming up tonight, can anyone at least give me a relationship and identity? It may not be direct, but it may lead me to where I want to go. Something to get started with an identity.
Tan squared plus 1 cosecant.
Go to me again.
Tan squared plus 1 cosecant.
Love it. Tan squared plus 1 is an identity, is equal to secant squared. It may not take me directly where I want to go, but that's true. Tan is -2. Let's put that in there. Plus 1 equals this. Guys, I think I end up with a 5 here. Now we'll do a square root, which at this point, of course, looks like this. I gotta be careful. Should it be plus or minus? And keep in mind, I'm in quadrant 4. And secant is 1 over x.
Plus.
Is x positive?
Yeah.
So it stays positive. So secant, with the help of my student there, is radical 5. Well, they didn't ask me to find secant, but I found it. They asked me to find cosecant. So I've got more work to do. Does anyone have an idea of what I can do from there?
Find cosine.
Okay, find what, cotangent? I heard, I think. Yes, no? Who said that?
Just find cosine.
Oh, find cosine. Hang on. Beautiful. So you're saying, Professor, if you know what secant is, cosine should be what? The reciprocal, which looks like this. Rationalize. Look at that. Now I know what cosine is, and it's a positive because I'm down here in quadrant 4. All the signs are good. Is that true, guys? But they weren't asking for cosine. They were asking for cosecant. I'm not finished. Now what?
Question. Could you do the cotangent squared theta plus 1 equals cosecant squared?
If you want to go directly, it might help be faster. But since Ignacio, absolutely you could. But since I started this way, I'm not quite to where I want to go. Help me out, guys, since you do have a quiz tonight.
For sine with cosine squared?
Well, like what, sine squared plus cosine squared is equal to
1.
1? It's a little lengthy. Here we go.
Here.
Ignacio telling me he's a shortcut. So this is sine squared. Cosine squared is radical 5 over 5 squared. This is sine squared. Guys, we're doing fairly quickly. I think this is 5 over 25 b squared. Is it 5 over 25 or 1/5? Reduce down. Move that over, subtract it from 1. Is it 4/5? Yes or no? Take the square root, and now be careful. I know that square root would be 2 over radical 5, or if I rationalize, clean it up, is it 2 radical 5 over 5? Is it positive or negative?
Yeah.
Negative. So I know what sine is. They were not asking for sine. They're asking for cosecant. Now what?
Cosecant.
Just take for sine's reciprocal.
Cosecant is equal to 1 over sine. They are reciprocals. The identity was listed like this. So let's go back to this answer, flip it over. Form the reciprocal, it's going to be a negative. And guys, I guess, oh boy, 5 over what? 2 radical 5 multiplied by radical 5. So it's a negative 5 radical 5. Is that a 10 on the bottom?
Yep.
You multiply by radical 5, top and bottom. And then cancel or reduce this down to a 2 here. Final answer should be this, if we have no mistake. Whew. Took all that because that's the way we started, and there's nothing wrong with that. Ignacio, tell the class what you thought of.
We could just use cotangent squared theta plus 1 equals cosecant squared theta.
He says, Professor, use this one. That's another identity. You'll be using these identities on your quiz here shortly. Okay, if I use that, they gave me tangent.
Would you do the inverse, which would be
Okay, and therefore I know what cotangent is, right?
negative 1?
Is cotangent what, negative 1/2?
Yeah.
So we put a negative 1/2 in here. Now, so you don't mess this up. So you did something like that, I guess. So that's what, 1/4 plus 1, that's what, 5/4? Which I like. Do a square root, is it radical 5 over 2? At this point.
Yeah.
But we said we're in which quadrant?
We're on quadrant 4.
And should cosecant be negative down there?
Yes.
Be plus or
Now, does he end up the same answer in just one statement? And we took all these other statements. It's entirely up to you how you approach it. Guys make sense? Now, I'm checking my time here. Whew. Okay. Shane,
minus?
I think flip it over, and I think it says solving equations. Okay, part 2. Gotta do it. Chapter 6 is closing down.
You know, solve the given equation.
Exactly. What was the first one they asked us to solve?
Cosine theta equals 1/2.
Cosine theta is equal to 1/2. Shane, class, did they have an inverse notation on that and restrict me? No. Did I say on the side there where to look for the answer?
No.
I didn't. Okay, they will in the textbook, and I'll eventually start doing that.
Some of them have it.
Some do. This one, guys, cosine theta is equal to 1/2. Your textbook likes to have you, as you can find the answers, all answers, caught between this. And I think he has this open now. So everything caught between in one revolution, we'll accept. There's no restriction on this, there's no inverse here. So directly, guys, where have you seen cosine, the x-coordinate, equal to a 1/2 on that unit circle? Pi over what was it? 3. And the other? I think I heard 5 pi over 3. You guys agree? Now, would those fall here?
Yes.
Will both those fall between 0 and 360?
Yes.
And those are the answers. Do I need to worry about restrictions? No, because there's no inverse notation here. Shane, tell me what the next one was.
Cosine of 2 theta is equal to 1/2.
Gotcha.
And it's gotta be between 0 and 2 pi.
0 and 2 pi, that's what the text looks like for you guys to do. I'll do the same thing. Now, gotta be careful. Cosine double theta equal to 1/2.
Would be 5 or 6.
Okay, this right here bothers me, this 2, was that 2 theta. But if you cover this up, this takes me back to up here, I think. And we've already said, if this were just blank in here, is the cosine equal to 1/2 these two numbers here. So that 2 theta is representing either pi over 3, is that true, guys? I'm gonna do this. Plus, the period to make it repeat is 2 pi. I'm gonna write that as 2 pi in. Or, the inside part could be representing, from my first part here, 5 pi over 3. Of course, plus 2 pi in would make everything repeat if I wish. Make sense, guys? But this inside part here has to be these. Is that true? As soon as this turn, if I erase this and put this in, is that a true statement? Or if I put this in, if it were blank, is that a true statement? So that means that inside there I had a 2 theta. That 2 theta must be representing either that or that. Now to solve it, I'm going to divide by 2 here. If I divide by 2, I'm going to end up with theta is equal to, guys, divide by 2, help me out, multiply by 1/2. What is that, 5 or 6? No, is it? Yep, divide by 2, 5 or 6. Plus pi n. Where n is going to be an element of the integers. That's division by 2. I'm going to set you up, I haven't listed the answers yet. I'll do the same thing on the second possibility, divide by 2 to solve for theta. Guys, I think it's what, 5 pi over 6, help me out. Plus pi n, where n is an element of the integers. Yes or no?
Where is the 2 pi n coming from?
Ah, beautiful. I'm placing this on the equations on the end, that's the period number, for a cosine. That's what makes things repeat. I think we said the period on the cosine graph, when I did the cosine graph, was 2 pi, wasn't it? That's 2 pi the period. So I'm adding this, Shane, good question. I'm adding this to the end to make things repeat just in case.
Okay.
So I could have lots of answers.
Uh-huh.
Okay, guys, we'll see if that happens. Are we okay with this? Now, I know it looks a little different. I'm going to do more of this on Wednesday next week. Okay. Now, let's replace n by an integer and start listing as many answers as we can, but we've got to make sure those answers fall between these two. So guys, I do it like this myself. I think it's a good case here. Let, in my first expression there, let n be 0. That's an integer. If I let n be 0, this term drops out. And leaves me for an answer of what? Pi over 6 or 30 degrees, which definitely falls between these two. I'll accept it. Let's see if I can find another one. Let n be 1. If I let n be a 1 in this expression here, this becomes pi over 6 plus pi. Help me out. What's pi over 6 plus pi?
5 pi over 6.
Ah,
Oh, no.
7.
7 pi over 6. Now, does 7, 5, or 6 fall between these two, as they would, these to fall in the textbook? Does it fall between 0 and 360, 7, 5, or 6?
Yes.
If it does, I'll accept it.
Yes.
Billy, maybe I can find more. So in that expression there, let's let n be 2. I can list these things all day, all integers. If I put a 2 in there, I get pi over 6 plus 2 pi. And pi over 6 plus 2 pi, common denominator and all that business, help me out, is how much? 13 pi over 6. Now, for the sake of you guys, I know and you know, if I convert this real quickly in my head, convert to degrees, I see 30 times 13, is that 390? If I convert it, is that 390 degrees? Is that gonna go beyond this? It works, but I can't use it. So this one's out. The only two that fall in the interval that will give to you, will be given to you in the textbook are those two. Even though 13, 5, or 6 does work, I can't use it. Okay? Now, Ignacio, I've got another one to consider. This one. Here we go. Let n down here be 0. Let's see if I'm on the right one here. Yeah. Let n be 0. And if I do, theta is equal to what? 5, 5, or 6, which is like 150 degrees. And definitely that falls here. I can use it. Maybe there's another one. Let n be 1. Let n be 1 here, guys. I end up with 5 pi over 6 plus pi. Help me out. Is that 11 pi over 6? 11 pi over 6. May I use it? Yeah, because I think it's like 330 degrees, which falls here. I bet if I extend and try 2, I don't think this one's going to work. But we'll try it. I'll put a 2 in there. I get 5 pi over 6 plus what? 2 pi? Help me out. What is that? 5 pi over 6 plus 2 pi. 17 pi over 6? Is it 17? 17 pi over 6? And I'll convert real quickly. That's 30 times 17. Oh, that's a big number. What's it, 510? I think it's 510 degrees. And you know, no way does it fit between these two. So the only two answers on that part there was this. Now, Shane and class, you say, Professor, where are your answers? Here's the problem. Where are the answers? We have these on placement of set. These are the particular solutions. I've got, let's put them in sort of in order here. I got 5 or 6. I think I have 5 or 6. I have 7, 5, was it? 7, 5, or 6, put it over here. And we're going to end this with 11 pi over 6. And those are my 4 answers. Yes or no?
No, don't be worried about the sign.
Oh, hang on. Now, first, do you guys accept that? Look at it closely. Yes? No? Then Shane, ask that question again.
Don't be worried about the sign,
Now, what signs are we talking about?
positive, negative.
Okay, now, here we go. They're asking me to find the cosine that should be equal to a 1/2. Mr. Park, don't write a program this time. I know on the unit circle, cosine of pi over 6, in fact, they could do this, is the x-coordinate of pi over 6, 1/2.
Yes.
So I know pi over 6 checks. If you check out the unit circle at 5 pi over 6, and you do a cosine, someone check it out for me. Cosine at 5 pi over 6 on the unit circle. Is it again 1/2?
No. Yes.
Yes, don't scare me. Is it 1/2? Shane, now 7 pi over 6, is that also on the unit circle?
Yeah.
Please check and see what cosine was. 7 pi over 6, was it negative? And was 11 pi over 6, help me out here. Where's 11 pi over 6 was what?
Negative.
Was that negative or positive? We're in quadrant 4, we're doing a cosine.
Positive.
Is it positive? In quadrant 4, 11, 5, or 6? Is it? That's 11, 5, or 6. What is cosine? X.
Wait, is it
Yes,
cosine?
it means-
Is
it
cosine
means
not radical 3 over 2?
Yeah. Okay, got you. Okay, now, so we got these, are these two okay here? You guys are telling me cosine is 1/2.
For pi over 6?
For 5 or 6, it's cosine 1/2.
I thought it was radical 3 over 2. Am I tripping? Is it radical 3 over
Did you guys give me the wrong numbers?
Is radical 3 over 2?
Oh, we're gonna do really well in that quiz coming up here
Yeah,
in
I
just a
think
few.
all of those are radical 3 over 2.
Yeah, and everybody smiled and said, oh, professor,
Well,
put this
I can
down,
give
put
that.
that down, and here we go through this. Please check, at 5 or 6, let me remind you, at 5 or 6, Billy said, wait, professor, 5 or 6, the ordered pair was this. Is that true?
Mhm.
Yeah.
And I was asking, where is cosine 1/2? Cosine's radical 3 over 2 there.
So it would be.
I just let you tell me. Is that true? Then you get your quiz back to 0. But I just let you guide me. I just wrote them down. Now, let's put it correct here. Billy, look at this. Actually, that's the point here. So here, it's not pi over 6, it is,
Pi over 3.
I heard pi over 3. It's right here. 60 degrees. Not this one, it might be, help me out, for cosine to be a positive 1/2, where's the next one will be? What size is it?
2.
5 pi over 3. I just did this on purpose, I just wrote the answers down. It's not 7, 5, or 6, is it, or are we done? Is 5, 5, or 6, 5, 5 or 3, guys, is that 300 degrees? You convert to degrees, is it 300? Or not?
Yes.
Well, we're tired tonight. Okay. I think those are the only two that will fit here. Are those the only two that will fit? You guys were just naming things for me. Shane says, watch out for your signs. Somebody said, watch out for square root 3. I was just placing everything you said. I just placed them on there. I was just placing these on there, not this. Well, this is maybe okay. We ended up with, for that final, where is it? Cosine equal to 1/2. Did we end up with pi over 3, 5 pi over 3? Now, did we do this one down here? Was there another one to be considered down here somewhere, where I erased it probably a little bit here? Was there another set down here to consider? We didn't consider this one, did we?
That included the other numbers.
Oh, did it?
Yeah.
Okay, so are we finished here?
Yes.
Ooh. Jeez, we are tired. Aren't we? We're tired. Not professor's tired, I just wrote down what you told me.
So did that mean all the extra work you didn't have to do?
And we didn't.
Okay,
But Bill, they told me to do it. They just,
so the 2 is just irrelevant or something?
Oh, hang on.
No?
All right, you're talking about, here we go, this right here.
Yeah.
Yes, I got you. That's what you're concerned about. As soon as I do this, Billy and class, I'm gonna set this equal to, back over here, I think we had a pi over 3 somewhere to work with.
It's right above it.
Was it? Okay. And then we did this, as soon as we do this, we're done. We don't have to worry about this 2 any longer. What you guys want to do is the 2 later. If you say, Professor, the answers are these 2, where they have marked some things out here. We said the answers were what? Remind me, pi over 3 and 5 pi over 3?
Yeah. That's
Okay.
exactly the same as-
Is that true? Do you think that's gonna work? And you're saying, Professor, I see a 2, the 2 bothers me. Am I supposed to multiply those answers by 2? Oh my Lord. Or am I finished? so glad this happened. Oh, I'm so glad this happened. This is gonna take me right into Wednesday. I can't wait now. I'm gonna enjoy my little short vacation, but I just can't wait to get back on Wednesday. With this setup here. Okay, guys, okay, now let's check the answer. Billy, here we go. Here, the original problem was here. And I'm gonna stop and save this for Wednesday. If, let's check it, cosine double, here's the check now. And we think one of the answers, guys, give me an answer. We think one of the answers is this? We think it is?
Yeah.
Okay, let's put it in. Now, if that gives me 1/2, I just replace theta by pi over 3. We're good. So this says cosine of what? 2 pi over 3? Is that true?
Yeah.
And one thing wrong with it right now, where's 2 pi over 3 located?
You're talking about degrees, one? Yeah.
That's like 120 degrees.
It's fucking
Quadrant 2, what's cosine in quadrant 2?
negative.
That can't be a positive 1/2, it's a negative answer. So there's something wrong here. You not see it, what happened? Oh, we don't know. Oh, I know, but you guys just, oh, I started listening to answers. Yeah.
Wouldn't that be the pi over 6?
Thank you, now would pi over 6 check? Here we go, did we not consider pi over 6 as one of the answers earlier?
Yeah,
Okay, let's see. Cosine double. And you said, oh my goodness, Professor, I did not know that involved. Now, I replaced theta by pi over 6. This was the original problem, I think, wasn't it? If it checks, we're good. This is cosine of, that becomes what, pi over 3? Now, can anyone tell me on the unit circle that pi over 3 is the x-coordinate 1/2? Pi over 6 is one of the answers. Ooh. Lord, I heard pi. I thought surely somebody's gonna give me pi over 4 as a possibility. Shortly, or pi. Or pi over 2. I know how students are, they start just grabbing everything. Professor, I'm gonna place all these down and let you select the answers, Professor. I'll list 12 possibilities. And I hope among those 12 are the ones you're looking for. Okay, guys, that sets me up though, perfect, sets me up for Wednesday of next week. Now, when you turn your quiz in,